Welcome back, CSC 121, to exercise 7, where we're working on RGB conversion numbers to hex numbers, and actually it's going to be hex letters as well. And in this part, we're going to be focusing on converting any numbers above 9, because that would make it 2 digits. We're going to use letters, because that's the way hex works. So let's convert those numbers using if-else statements. So we're going to do this before the print statement. So before we print anything out, we're going to kind of move this down a little bit, and we're just going to make a little comment here and say convert 2 digits to letters. We know what they are, but we could just do that here. So we're going to say if hex 16, we'll do the first one first, because they could both be above 9. So we're going to do hex 16 first. So we're going to do hex 16, and we're going to say if hex 16, and we're going to do each one. So we're not going to do greater than or anything. We're going to do equals equals. So we're going to compare. So if hex 16 happens to be 10, then hex 16 is going to be reassigned to the value of A, and it's going to be a string, and I'll put the quotes first. So that's our first part. So if that's the case, and then we're going to use elifs. Now, in the old video, I mentioned why to use elifs, because you can just use ifs, but I'm not going to bring it up right now, but there is a reason why to use elifs, as far as it keeps comparing things. So we're going to use elifs, so we're going to keep it moving along here. So I'm going to put elif, and we're going to use multiple elifs, just like we did with the letter grade, and move it out. And now we're going to do, I'll copy this here and just put this here. And if we do 11, it's going to be B. And now we could just copy these. I'm even going to copy a couple here. We don't need that many. We only need to go up to 15. So this one would be 12, and this would be C. And there could be other ways to do this, you know, to put them in a list or something like that. So right now we're just focusing on this. This may not be that efficient, because later on we may want to do something in a list, but we didn't get to list yet, so we'll focus on doing it this way for now. We'll use what we know before moving on. I know there's always ways to figure it out, and you could look up things, but I always want to use what you know first and then build on it and then find something more efficient. So you know, we're kind of doing it the manual way here. Is this right? 10, 11, 12, 13, 14, and then, oh, this one should be E. I was wondering why. Okay, that one should be E, and then our last one should be F. And that's as high as it can go. So what do we put for else? Well, there won't be anything here unless people put in a number that doesn't really work. So what I'm going to put here, I think for now, I'm going to put an else, just in case somebody puts anything that's not one of these. If I just put else, and then I'm going to put hex 16 equals, and I'll put please enter 0 through 255. We'll use that as a little catch in case somebody puts something else in. We'll see how that works. I don't remember exactly how I did it in the past, but I did something like that. So we're going to put our else. If it's none of these, let's just say we can enter that. So at least to catch it. Now, we don't have to. We could just leave the last one at elif. We don't have to finish it off with an else. But here, that way it's going to catch something that doesn't fit. So let's just see what happens here. This will just get the first part. So the second number will still be the 2 digits. This should catch the 2 digits for the first one. So let's see what happens here. And I'll just jump right in and put 255. And it's doing F15. Perfect. That's what I want. And how about if we do 256? Let's just see what happens here. And it says, please enter 255. And maybe we can put an exclamation point, just so we know. But it's still putting the 0, so it's still figuring out the other one. So we're going to have to do something with that. Now, we also have to do letters for the hex 1s, because we want to convert them as well. And because that came out to 0, which it's probably right based on the math, we want to convert that one also. So how do we do that? Well, let's just copy this. We're going to copy this whole thing. And paste it. Now, I just want to show you something here. we copied all these and we want to change these to 1. Now, if you had to do a lot of it, that's a pain. Now, there also is something, if you right click on this, they have something where you can rename all occurrences, meaning you could change all your variables named hex 16 to something else. But the problem is we don't want to do that here because it'll change our first ones. So we don't want to do that. But another thing you can do is if you change this to 1, that'll be hex 1, and I copy this. I could highlight this and copy it. I'll do Command C. You could do Control C. And then if you hold Option and highlight that, you could highlight that. You could use Option or Alt. On Windows, you would use Alt. And you could highlight all of these and do multiple highlights. Now, on Windows, Alt isn't working. Maybe Control will work. But for me, it's Option. And I'm assuming on Windows it would be Alt. But that way I'm highlighting all of those, and then I could just type hex 1. I could change them all at one shot. And that's one way to do it. And you could also change all occurrences. So if I ever wanted to go back and make these all like HX1 or something, I could do that. But I just wanted to point that out. So now I have all of these, and these should all work the same way. And this one should be hex 1. I didn't highlight that one. And I'm not sure what's going to happen here, because it should still go through and do the number unless one of the numbers is out of the range. And that might not work. But let's just see what happens here. Let's run this, and I'm going to just put in 0. And it's saying, please enter a number 0 through 255. Please enter a number from 0 to 255. Now, why did 0 not work? Now, what's happening here, because we threw this else in here, if you think of what's happening in the program, it's generating a number, and then it's going through here, and it's saying if this, if that, and then if it's saying if it's else, then it's actually putting that in. So that's replacing our first number. So it's only looking for these now, and if it's anything else, it's wiping out our original number. So let's comment this out for now, because this is giving us a problem here. I'm going to comment that out, because that else is giving us a problem, because it's going back and kind of wiping out any other number other than these 6 numbers. And I'm going to do the same thing here. I got ahead of myself. It was a good idea, but let's keep them out for now. Let's get this to work first, and then we'll see how we can catch things that don't work. And that's really the process we should be doing. We shouldn't be thinking too much ahead. We should be getting it to work first. So let's get it to work first. Let's try this again. And let's put in 0. And it's giving me 0, 0. Perfect. That's what I want. And let's run it again, and let's try 255. Perfect. FF. That's what we want. And if we don't want a space there, now we could put these together, because I put them apart because it was hard to see that decimal next to it. So let's put these together now, and let's try it again. And we should do a 0, and it should be 0, 0 right next to each other. And if we do it again for 255, we should get an FF. So that's right. And what if we put in 256? Okay, we are getting a number, but we should find a way to try and catch that. Now, there is a way we can put, if the number is greater than there, we can actually print this number out, instead of just saying else, because else is wiping it out. So up here, maybe we could just put another elif. So I'm going to uncomment this. And I'm going to put one more elif. We can't use else, because that's wiping out our first number. So we're going to use elif, and we're going to say if someone puts in a number that's greater than. And again, there's a whole bunch of things we'd have to worry about. We'd have to worry about what if they put in letters and all kinds of stuff like that. So we're not going to worry about catching everything right now. But if someone put in a number greater than 255, let's just put in a message saying if x16 is, we want greater than 15, I think. Let's try that out. There we go. Please enter 0 through 255. That's what we want. That's correct, except it's still putting a 0 there. So how do we fix that? How do we fix that so it's not doing that? So it doesn't do anything else. We could even put a nested. If hex 16 is equal to please enter that, then hex 1 equals null, or try again, or something like that. So let's try that. Let's add to this. Let's make this an elif, and let's make one if in front of it. I'm going to put if, and I'll hit return. And we're going to say if hex 16 equals, so if it equals that, so if somehow that got converted because someone put a number for the first number over that, what are we going to do with hex 1? Then we're going to say hex 1 is equivalent to, and maybe we'll put a space, and we'll just put run again, because that's all we're doing right now. We're running it, so not rub. We'll try run. So we'll try that. So hopefully, if there's a number above, it should say please enter 0, and then it should basically rewrite hex 1 to be run again, and then it shouldn't go. Then it shouldn't do anything else to hex 1. Supposedly, that should be the case. So let's see what happens. Again, we're just trying to break it here. Now, obviously, if we put in letters and things like that, it's going to create problems. But let's just try a number above 255. Run again. Okay, that's fine. We could say run program again. We could put another exclamation point just so we know it's some kind of prompt. Now it's showing the pound sign. That's okay. It is putting the pound sign in there, which we can make another statement or something, but you know, that basically backspaces the pound sign. I don't know if we could backspace the pound sign and get rid of it, if it would actually get rid of it. But I think for now we're okay. So I don't think I'm going to do anything else with this right now, because we can keep looking at how to break it. You know, there's all kinds of things. If we put in letters, we get an error. So it's not going to like putting in strings in there, because we're trying to do work with math. So that's going to be a problem. So that's where we start to really get into more planning, because there's a lot more planning to happen here. We're trying to work with numbers. What if somebody does this? What if somebody does that? We can't control everything that people put in, but sooner or later we do. Because, I mean, you fill out things that you fill out wrong, and it gives you error messages, and you have to fix it. So that's kind of what we're doing here, but at least we're getting our RGB. I mean, what we really wanted to do was be able to convert RGB numbers to hex, and that's working. If someone wants to type in other stuff, you know, that's an issue. That's trying to control all the variables that people put in there. So we're trying to do that a little bit. So we even controlled putting a number above there. You could have something where if hex 16, if its type is a string, meaning they typed a bunch of letters in, you could have something, you know, that's another condition that we could put in there. If they threw something in where you test its data type and it's a string, you could say please enter a number or something like that. But there's a lot of stuff we can do. But right now this is working. Hey, one thing I just wanted to point out, when I was editing the video and watching some of the things I did, I realized I probably could have took this line, this hex 1, instead of making this F and continuing the LF, I could have probably just took this line and just put it here. And then it just had 2 results instead of like repeating that. So I'm just going to take this out of here and put if back and just keep it the way it was. That way, that could be taken care of just like that. And then also another thing, to get rid of that pound sign, I mentioned something about we can backspace, and we can. I went to Python escape characters, and they have a backspace character. Now, I wasn't sure if that would work through the print statement, but it does. So what you can do is use let me show it again. It's \b, and you just put it in with the string. So if you just go here and put a \b, and we run the program here, and we'll put in 256, just like we were messing with, the number that's above 255. Now it'll say, please enter 0 through 255, and it'll say run program again. So it takes away the pound sign, and it also runs this, and it skips doing this, because now hex 1 is using this, and it's not any of these. So hex 1 is now run program again, so if it does go through here, it's not going to be any of these values. It's not going to be equal to 10, 11. Once hex 16 is this, then hex 1 becomes that. Now that's what we did there, but this just does it in one shot right here. So this is just more efficient, and the backspace gets rid of the pound sign. So just wanted to point that out real quick. Let me just make it work one more time. Instead of all these errors we're putting in here and all these weird numbers, let's just put in a number like 155 and see what happens. There we go, 9B. So that's working. So we have it working. Now we don't have it for 3 colors. We could figure out a way to do that. But for now, this is all we wanted to do with this exercise. So it brought in the idea of using elifs. It brought in the idea of what if we had something that was out of that range, and you can't just use an else here, because then it wipes out our original value. You know, then it just goes here, and if it's not any of these, it's like, well, then it's nothing, and then it wiped out what we originally had. This is only catching if they're these numbers, so we don't want to wipe out the ones that do work. This is only catching these 6 numbers that are above 10 through 15. So And here we just threw in 1 for greater than 15. And because it was still doing the other number, we had to throw in this little thing ahead of it here. So hopefully that's okay. I guess we don't need anything down here then to do that. So we're going to stop here. So when you're done with your exercise 7, we're going to copy this. And again, we'll look at different things. We'll even look at how to convert hex back to RGB if we have to. Now that would be a lot harder. It's easier to convert a number into a letter than trying to get a letter and convert it into a number, because that's a little more odd. But hey, that's what we're here for, to try and problem solve and figure that out. And we can't just say, that's too hard. There's got to be a way to do it. Maybe it's not that hard. So we may look at a way to do that as well. So that's exercise 7. And when you're done, copy that and put it in your comment for exercise 7. And we'll keep moving on.